again, in this example, the first thing we can do is compare the integral that we have been given, 1 over 25 plus 4x squared, with the formula that gives us inverse tan of x on a plus c. If we compare the two formulas though, there are two things you need to note. Firstly, in front of the x squared in the formula, there's the number 1. In the question that we're looking at, there is the number 4. The other difference is in the top line of the formula, there is a number represented by a. In the question that we have, there is the number 1. So there are two things that we're going to need to take account of as we're solving this problem. So the first thing to worry about is the number that is in front of x squared. Like we did in the previous example, what we're going to do is take 4 out as a factor on the bottom line. This will give me the integral of 1 over 4 times 25 on 4 plus x squared dx. The next thing to see by observation is if we're looking at the formula on the bottom line, there's an a squared. So what we have is the integral of 1 on 4. What number do we square to give ourselves 25 on 4? That number is 5 on 2, so it's 5 on 2 all squared plus x squared dx. So at this point, what we have is we know a will equal 5 on 2 because it is that number which is being squared. We have two ways to proceed from here. I'm going to take out the 1/4 out the front of the integral sign at this point. I've got 1 on 4, integral 1 on 5 on 2 squared plus x squared dx. I could have left the 1 and 4 in there, but it just would have made it a bit messy. Our problem now becomes, we know the value of a is 5 on 2, which means we need to get a 5 on 2 on the top line. Now what we're going to do here is use a mathematical trick. What we do know is on our top line, we have the number 1. We need to get the number 5 on 2. Now 1 does not equal 5 on 2, but 1 does equal 5 on 2 times 2 on 5. So the way in which we approach this is we look at that top line now and say, my top line is 1. That is the same as writing 5 on 2 times 2 on 5 over 5 on 2 all squared plus x squared. Now comparing this to the formula, on the bottom line, we've got the 5 on 2 squared. On the top line, we've got the 5 on 2, which is our value for a, and we have the x squared. What we do not need within the integral sign is the 2 on 5. Now 2 on 5 is a constant, so I can take that 2 on 5 outside the integral sign. So I now have 1/4 times 2 on 5, integral of 5 on 2 over 5 on 2 squared plus x squared dx. The 1/4 times 2/5 will give us 1/10. The integral part we can work out simply by using the formula. So we have inverse tan of x divided by a. A was 5/2 plus c. Tidying that up, that is 1/10 inverse tan. Dividing by a fraction, we turn it upside down and multiply, so we get 2x/5 plus c.